What's going on, guys? It's New York Prepper here, and in this video I'm just going to explain to you guys the solar minimum. Everybody's talking about the solar minimum, and the solar minimum is something that I've been following for probably over 10 years now. I've been following the solar minimum, and people are just starting to talk about it now. So I consider myself to be kind of an expert on this subject, and because I've been following it for so long. So I wanted to just do this video to explain to you guys, in layman's terms, what the solar minimum is, and try to explain it to you guys in a way so you can understand it, okay, without getting too technical and too scientific, So we need to, first, before I get into the solar minimum, we have to just cover some basics. And, we are in the middle of the coronavirus pandemic, and I actually got my hair cut. And I don't know if you guys can see, I got my hair cut. And how did I get my hair cut? I didn't go to a barber. I didn't go to a salon. I just bought myself a razor, a barber shop, electric razor machine. And I had one of my family members cut my hair for me, okay? So a lot of people are complaining that they can't get haircuts. And, people are saying, oh, man, I can't get a haircut. Guys, it's called $50, a Conair electric razor. And, have your wife or, have your parents or something, cut your hair, okay? It's not hard. If they've never done it, now is a good time for them to learn. So I recommend that to you guys, all right? So don't freak out about not getting a haircut. So, all right, so we have what's called a grand solar minimum, and that's supposed to last from 2020 to 2050. And then it could lead to a possible ice age and global cooling, all right? In addition to global cooling, we could have other issues arise from a solar minimum. So basically a solar minimum is, I'm going to explain what it is, but it could lead to an ice age and global cooling. And if there's global cooling or ice age, we could have famine. Okay, we could have famine. We could have pestilence. Okay, those are some big threats right there. Because there's going to be crop failures. If the globe cools down, then, there's obviously going to be some crop failures. Okay, so we're going to have famine and possibly pestilence as well, because you're going to have colder temperatures. And colder temperatures always cause, pandemics to arise, just like the Black Death, which, happened during an unusually cold time period, the Black Death, which was the bubonic plague. Cold weather can increase, pestilence also because, your immune system gets weaker. People's immune systems naturally get weaker when it's colder outside, so that could increase the chances of pestilence, crop failures from the cold, longer frosts that last longer into the spring and kill sensitive, crops, and even summertime frosts and freezes could lead to crop failures. And we could also have, cattle getting sick and dying. If it gets really cold, cattle can get sick, and all kinds of different diseases can arise from the colder temperatures, because cattle are not really made for cold weather, so their immune system may get depressed, and so we could have cattle dying off as well. So those are the big threats with a global cooling period. So that's what you would need to prepare for. Obviously, we could also have, other issues arise from global cooling, which could be economic issues. Always goes back to the economy, all right? The reason why it would go to the economy is if we have really strong winters and, first of all, the economy always contracts in the wintertime. So if there's really strong winters, you know, a lot of businesses that are seasonal are going to be shut down longer than normal. People generally don't like to go out and spend money or go on vacation if it's cold outside. They basically stay indoors. So it'll affect the economy. And also, you know, also it could cause, you know, human death and suffering from, you know, severe blizzards. And, you know, during a global cooling period, the blizzards are a lot worse. And, you know, so you could see people just dying off, freezing to death, you know, and loss of life, okay? Especially in a modern society where people are very reliant on transportation and roads to be clear and not so there's no snow on them. And if roads are constantly covered in snow in areas that are not used to getting that snow, then we could see, you know, a lot of issues arising. A lot of municipalities could also go bankrupt trying to spend money on snow removal. I know it sounds pretty crazy, but in 2010 we had a really bad winter over here in where I live in upstate New York in the Hudson Valley. And my local town, they didn't allocate enough money for sand and salt, and they ran out of money. They spent so much money on plowing and salting and sanding that the town pretty much went bankrupt almost, okay? So it could have economic effects, all right? So those are the main effects that you would want to prepare for. You know, we could obviously see the usual, you know, SHTF things. We could always have civil unrest, you know, people getting mad, you know, that the government didn't warn them in time for the global cooling. You know, we could have crime, you know, because people are going to be more likely to commit crimes in a global cooling period because especially people that may not have prepared well, and they may be looking for more resources, okay, if they ran out of food or something. So these are always going to be your threats, you know, crime, civil unrest, other people, basically, economy, pestilence, and famine. All right, so those are your main threats from global cooling and from which could occur from 2020 to 2050. All right, so now I'm going to explain to you guys how that happens. All right, how the solar cycle, how the solar minimum occurs, and how it works. Okay, so stand by, and I'm just going to start over here and draw it out for you guys. It's really simple to understand. Okay, so you have what's called a solar cycle. Okay, so I'll write that down. Solar cycle. Okay, solar cycle, and solar cycles are basically variable. That's why it's called a cycle, and they vary every 11 years. And I'll just draw a little diagram here so you guys can understand. Okay, so these are solar cycles. All right, these humps here, the peaks over here. These peaks are the maximums. Okay, that's what you would call a maximum. Okay. All right, hopefully you guys can see that. Let me just bring it up a little closer so you guys can see. All right, so these are your maximums, and then the bottom here, these are what you would call your minimum, okay? Solar minimum, as they're saying now on TV. Everybody's talking about it. So this is your minimum, okay? Let me just angle the camera down. Okay, so, and these cycles are typically around 11 years, okay? All right, 11 years typically, all right? They can vary a little bit, okay? They can go up or down, you know, 1 or 2 years. They could be 10 years. They could be 8 years. They could be 15 years. I think the longest cycle was 15 years, and the shortest was 8 years. All right, so they can vary between 8 and 15 years, but the average is 11 years. Okay, and they go up and down, and what this cycle is the number of sunspots. Okay, that's all it is. All right, sunspots. Let me write it down here. Sun spots. Okay, that's what it's counting. All right, sunspots. What is a sunspot? Okay, a sunspot, if you were to look at the sun through a telescope, all right, so here's the sun, all right, that's the sun, this round thing here. Okay, this is the sun. If you were to look at the sun through a telescope, you would see little black dots on it. Okay, very little dots. Okay, that's all you would see, is these little dots on the sun. And what these little dots are basically, in layman's terms, like explosions on the outside of the sun. All right, they call them coronal mass ejections. All right, coronal mass ejections, CME, and I'll get into that in a little bit. So these are just little explosions on the surface of the sun, and these explosions, they look small. All right, these explosions look small, but they're huge. All right, because remember, the sun, if I were to compare planet Earth to the sun, the planet Earth would not even be visible here. All right, the sun is trillions of times bigger than planet Earth. All right, planet Earth is like a speck of sand compared to a bowling ball. All right, that's the best way I can describe it. So little speck of sand is what Earth is. So these ejections, these explosions, these sunspots are bigger than planet Earth. Okay, they're huge, massive eruptions of radiation coming off of the sun, and they're caused by magnetic fields. All right, there's the sun has a magnetic field just like planet Earth, and there's still a lot of unknowns about the sun, because we can't obviously go up to the sun and study it, because it's so hot, and it's millions and billions of degrees Celsius, and you can't even get close to the sun. We can't even send satellites close to the sun, because the satellites would melt. All right, so we can't even get close to the sun at all. So it's hard for us to really understand a lot about how the sun works. We don't understand the sun as well as we understand planet Earth. All right, planet Earth we can study. We know that there's a north and south pole. We know that there's a ionosphere. All right, but the sun, there's a lot of mysteries. All right, it's one big mystery. We don't know how the sun works. We don't know much about it. All right, but we do know that the sun is magnetically active. Okay, it has a magnetic field of some kind, just like planet Earth. But the magnetic fields are they're not as constant as planet Earth, where you have the North and South Pole, and it's pretty much going to always be there. It varies a little bit, and it drifts, but for the most part, we have a North and South Pole. The sun is different, and sometimes what happens is you have magnetic fields that come out of the sun, and they cause the ejection of radiated material. The magnetic field inside the sun causes this eruption. That's how it happens. It's not like a volcano or anything like that. It's not like a explosion per se. I'm just trying to get you guys to understand it in a common way. So it's not really an explosion like a volcano. It's basically the bending of magnetic fields that causes an ejection of material. All right, they call it the corona. The corona, interestingly enough, is the outer part of the sun, and that's where you have very hot material, and that's the bending of that magnetic field ejects that corona. The mass from the surface of the sun gets ejected off the surface, and when it gets ejected, what happens is it releases solar winds. Okay, let me see if I can write it here. Solar winds. Okay, solar winds. All right, it's kind of a funny term, solar wind, because there's no wind in space, but it's not really wind. Okay, what it is a stream of radioactive particles that are ejected from the sun, and depending on what part of the sun they're located, if they're earth facing, so if you have one of these ejections that are facing earth, you're going to have those particles are going to be heading towards earth, okay? And when they head towards earth, they interact with our atmosphere, and that's when you get aurora borealis, which is northern lights, okay? I'm kind of writing all over the thing here. All right, so solar winds will cause aurora borealis, okay, which is caused by coronal mass ejections, which look like spots on the surface of the sun, okay? So if you were to take a telescope and you look at the sun, you know, that's what you would see, these little spots, which represent the coronal mass ejection, all right, CME, coronal mass ejection, which causes a solar wind, which causes aurora borealis and northern lights, okay? So here's where this ties into the solar cycle. You know, I'm sorry that this is like a classroom, but that's the best way to understand it. So what happens is, during the maximum period, okay, these maximums, remember I said it was 11 years, the solar cycles? During the maximum period, these little peaks here, that's when you have the most amount of coronal mass ejections on the sun. All right, and they call them solar flares. Okay, solar flares is another word. So let me write solar flares. I don't know where I'm going to write this. I'm running out of room here. Solar flares. Solar flare. Okay. Okay, solar flares. That's what they call them, or coronal mass ejection. All right. During the maximums, you have more of these explosions here, okay? More solar winds, and so you have, if there's more solar winds, there's more particles from the sun. Theoretically, that could cause a warmer climate. The more of these flares, basically this means that the sun is more active, okay? When there's more flares, the sun is more active, okay? And a lot of people think that there's a connection between how active the sun is and how much and the climate, basically, okay? So you know, if you have more sunspots, you have more flares, more coronal mass ejections, more solar winds, more aurora borealises. We also had the Carrington event. All right, if you guys don't know what that is, look it up. It was a huge solar flare, okay? Carrington event. I'm going to circle it because if you're a prepper, that's a very important thing to know. All right, Carrington event. Look it up. All right, Carrington event was a giant solar flare that occurred, I think it was like in the mid-1800s, I believe, or 1900s. I can't remember. But it was such a powerful solar flare that it caused people in the tropics to see northern lights, all right? Normally, northern lights, you only see them in Alaska or Canada or places that are much more of a northern latitude. And the reason why is because when the solar wind hits planet Earth, it interacts with the atmosphere, like I mentioned. And I actually don't even know. I should research that myself. But basically what you need to know is when there's stronger solar flares or more of them, the stronger that they are, you could even see northern lights as far south as the equator. All right, and during the Carrington event, there were northern lights spotted in the equator, okay? And it caused all kinds of problems with, when you have a solar flare, it's like an EMP, basically. It can affect the telegraph, like back in the day, it affected the telegraph systems that they had. It affected the power, electricity, all right? So that's a good thing to know about if you're a prepper is solar flares, okay? A solar flare is the equivalent of an EMP. All right, so basically when you have a more active sun, more solar flares, that means that theoretically there's more radiation reaching planet Earth from the sun, which would theoretically make the Earth warmer. Okay, it's just like a wood stove. All right, if you have a wood stove and you put more logs in it, it's going to get warmer, right? If you sit near your wood stove and you throw a log in it, it's going to warm up more, okay? And a lot of people think that the sun, which is basically our wood stove, the more flares there are means that it's more active, so there's more radiation reaching Earth, which means that the climate warms up, okay? So now I'm going to explain to you guys the concept of minimums and maximums. It's a little bit, so they don't know why. So like I said, during the maximum period, you have more of these flares, right? And then you have what's called the minimum, which is what they're talking about now, the solar minimum. And that's when the sun is blank, okay? There's no flares, all right? When you look at the sun, it's just blank. There's no flares on it. All right, so here you have more flares during the minimum, or you have no flares or very little flares during the minimum period, all right? And so a lot of people think during minimums, the climate has a tendency to be cooler. So if, let's say the minimum here would be like, let's say 2019 to 2020, which we're in a minimum now. During that minimum period, a lot of climatologists believe that those years where the minimum is are usually cooler, okay, because there's less radiation from the sun. And this cycle is normal. It's been going that way for hundreds of years, okay? So, and people don't really know why it's 11 years. They suspect that the magnetic field flips and stuff like that, but they don't know why it's in that 11-year cycle. And it's almost a perfect 11-year predictable cycle, to the point where scientists can actually predict how many sunspots are going to be on the sun, okay? Every cycle, they issue a prediction for the next cycle of how many sunspots they expect to see, okay? How many flares, all right? They can predict how many flares they're going to be. That's how accurate it can get, all right? So now if you need to save this, you can take a screenshot if you want. I'm going to erase this now, all right, because I got to move on to the next thing, all right? So the next thing is going to be an important number, which is the sunspot count, okay? The sunspot count is basically how many solar flares there are in the cycle, okay? So you have that 11-year cycle. How many sunspots total in that cycle is what the sunspot number is, okay? So that's the measure of how active the solar cycle is, all right? It's sunspot number, okay? Sunspot number. This is turning into a astronomy class, all right? So sunspot number is the number of solar flares, basically, or as observed, as observed as a sunspot during the whole cycle, all right? That's what the sunspot number is, all right? So, scientists can actually predict how many sunspots are going to be in a solar cycle, all right? That's how they're pretty accurate with it now. So that's how we keep track of the solar cycles and how active they are, is with the sunspot number. And basically all they do is they look at the sun every day and they count how many spots there are every single day, all right? And they name each spot, so let's say this spot is going to be A123. Then this spot here is going to be A124. And then this spot is going to be A125. All right, they name every single spot, so this way they don't double count it, okay? Let me make these spots bigger so you guys can see. So that's all they do, okay? They have that telescope pointed at the sun, and what they do is they count and name every single spot, okay? And that's how they keep track. So then let's say after the cycle is over and it's a rolling count. Okay, they count it every single day. All right. Another thing they count is the number of spotless days. Okay, number of spotless days, and that's another way you can keep track of how active the cycle is and how deep the minimum is and things like that. Number of spotless days. So that's just how many days, when you look at the sun, how many days do you see it with no spots at all, where it's just a totally blank sun, no spots, all right? How many days? And so what they do is they count every single day. So let's say today there's no spots, tomorrow, and they do a percentage of how many days per year of every year during the cycle. And then let's say like 2019 was 77% no spots at all. 2016, 70%, all right? And as you go up into the maximum, you're going to have less spotless days, all right? When you're in a minimum, there's more spotless days, all right? So the sun looks like this during a minimum, and during a maximum, it looks more like this, where you have a lot of spots going on, you have a lot of flares, okay? It's very active. So these are kind of the principles, and now I'm going to get into the grand minimum and why that's important, and I'll cover some other things as well. So one word that you should familiarize yourself with is, so you have total solar irradiance, okay? Total solar irradiance, all right? Total TSI, that's what it's called, TSI. And that's basically the total energy that comes off from the sun. How much energy is the sun putting out? All right, think of like a thermometer. If you have a wood stove, and you want to know how hot it is, you have a thermometer to tell you how hot it is. So TSI, total solar irradiance, tells you, how much radiation is the sun giving off. And a lot of people think that during minimums, well, it's not that they think, it's proven. It's proven that during a minimum, you have lower solar irradiance, okay? All right, lower solar irradiance during solar minimums, all right? And like I said, minimums are normal. They happen. It's a cyclical thing. What's really concerning is a grand solar minimum. And so what that means is, rather than having a normal cycle, all right, so if you have your normal cycle like this, what will happen is a couple of years you may have a lower cycle. Some years you'll have a higher cycle, some years lower, and then you'll have a minimum where there's no maximum at all. And then maybe it'll come up again and then go back up again, okay? This is what's called a minimum, a grand minimum, okay? So I'm going to redraw that on a big screen, but basically during the minimum here, so these are the maximums, as I mentioned. As you see, sometimes the maximums can be lower. They have a lower sunspot number, and they have more spotless days and a high and lower sunspot numbers, all right? And they call those, they're just weaker cycles. For whatever reason, you have more potent cycles and you have weaker cycles. And I'm going to explain that in a little bit. And then you have a grand minimum, all right? So here, this flat line is what you would call your grand minimum here, all right? Grand minimum. And what that means is, rather than having the normal 11-year cycle, okay, let's say this is 11 years, 11 years, okay? This is your normal 11-year cycle here, right? This is, it basically, what happens is it never goes up to maximum. It just stays on a minimum level, and you have that empty, oh, whoops, sorry about that. Drop my pen. You have that empty sun, okay, with no sunspots at all during the grand minimum, all right? And theoretically, that leads to less total solar irradiance, which a lot of people think could lead to global cooling, okay? Because, as I said, it's like a wood stove, right? If the wood stove, if there's less logs in the wood stove cools down and you start to feel cooler, all right? So a lot of people think that when there's a solar minimum or a grand minimum, that means that the sun is not putting out as much energy and it's going to cool down the earth, all right? That's all it is. And so what a lot of scientists believe that we're heading for a grand minimum, okay? Which is what is this section here. And I'm going to just redraw it bigger for you guys. I'm going to explain the timeline because that's important as well. So I know this is kind of a science lesson. I'm not a big science guy, but, you know, it's very interesting stuff here. So in our example, you know, we had the, so this is where it really gets fun. All right. I always like to save the best for last. So here we have, I'm going to show you guys something cool here. So here we have the cycles. All right. And then here we have, I'll show you guys something. All right, so here we had a minimum from 1650 to 1750 or so, and that was called the Maunder Minimum, okay? Maunder Minimum, okay? You can look that up online if you want to, all right? You can Google that, all right? Maunder Minimum, all right? That's 100% real. I'm not making that up. It was called the Maunder Minimum, and it was 100 years, okay? 100 years where there was no sunspots counted, and believe it or not, even in the 1600s, they had telescopes back then, and they had a little journal, and the astronomers would write down in the journal how many sunspots they see every single day. They would sketch it, all right? They would sketch the sun, what they saw on the telescope, and they would sketch it. So that's how we know that this minimum existed. All right, this was before, you know, the satellite era where we have satellites and telescopes in space. This was back when they were using, you know, old-fashioned telescopes and looking at the sky and doing everything manually. All right, they were writing down the sunspots that they saw every day, even in this time. So that's how we know that the Maunder Minimum was real. All right, and coincidentally, okay, during this period, we had what was known as the Little Ice Age, all right? During the Maunder Minimum, we had the Little Ice Age. And, you know, during the Little Ice Age, there was what they had all, it was global cooling. So the Earth's temperature dropped, you know, at least a couple of degrees, okay, for a long period of time during this minimum. All right, so this is why a lot of people think that when there's a minimum or a grand one, a Maunder Minimum, this is, so using the Maunder Minimum as an example, that this is why people think a grand minimum can cause global cooling, because during the Maunder Minimum, we had a Little Ice Age, all right? There was also the Dalton Minimum, okay? Dalton Minimum, which was in the early 1800s, okay? That was like 1800 to maybe 1820 was the Dalton Minimum, okay? Dalton Minimum. You can look all these things up, all right? Dalton Minimum was also a shorter minimum. It was like from solar cycle 4 to solar cycle 7, all right? So it was roughly 20 to 30 years. And it was also, during the Dalton Minimum, we had the year without a summer. So let me write down Little Ice Age. You can Google all this stuff if you don't believe me, all right? Little Ice Age, all right? And then here we had the year without a summer, okay? Year without a summer. And it's exactly what that means, is there was a year in 1816, okay? 1816, you had the year without a summer, okay? Now, a lot of people think the year without a summer was caused by the eruption of Mount Tambora. But some people believe it was also during the Dalton Minimum caused by that, all right? So during the Maunder Minimum, like I said, when there's a minimum, you have less radiation from the sun. A lot of people believe it caused the Little Ice Age, all right? And during the Little Ice Age, you had there was a lot of evidence. You can look up paintings. There's actually paintings on Google of artists from back in that time, and they painted the landscape. And there was paintings of the river in London, the Thames River, the river that goes through London, would basically freeze every single year, and they would have frost fairs on the river itself. Okay, frost fairs. They were like flea markets that they had on the river. All right, the river would freeze solid, and they would have flea markets and stuff. All right, that's how cold it was. Can you guys remember any time in your life the river in London freezing over solid enough to where they could have flea markets on it every single year? Absolutely not. I can't remember that, and it probably hasn't happened since the Little Ice Age. All right. So during the Little Ice Age, we know it was extremely cold. We also know that even during the American Revolution, it was extremely cold during the American Revolution. If you look at paintings and stuff from the American Revolution, they're always wearing coats, and during Valley Forge, it was very cold. So this was a very cold period, and that was caused. A lot of people think it was caused by the Maunder Minimum. So that's the possible theory behind a grand solar minimum, which they're predicting could go from 2020 to 2050. Okay. All right. So I'm going to move on now to how this relates to what we're dealing with now, and why it's why there's going to be a grand minimum. All right. And I'm going to explain the last 20 years and show you guys the potential for something to happen. I'm not saying it's definite. I'm saying it's possible. Even scientists themselves don't know what the future holds. All we can do is do our best guess, But so right now we're about to enter solar cycle 25. So let me just draw the last couple of cycles here. All right. So here is solar cycle 23. This is solar cycle 24, and this is I'm sorry, I made a mistake. This is going to be solar cycle 22, 23, and 24. Okay, this we're just getting out of solar cycle 24. Okay, hopefully you guys can see that. Let me fix this up so you guys can see. All right, there we go. All right, so this was from this. We just ended it. All right, so 2020, and I have to take a educated. I'm gonna try to do the best I can in guessing, but I think it started around 2008 or so, and then it let's see, 2008, and then I think, what did this go back to, like 1997? And then 19, what is that, 80, let's just say 88 or whatever, 1985, I think. I don't know, I'm just guessing. All right. So this is the most recent cycles that we've had. All right. Let me see, can you guys read that? I don't know if you guys can read that. Looks like you should be able to. Let me just clean this up a little bit. Let's just take a guess here. 1985. All right. So solar cycle 22, as you can see, solar cycle 22 was very high. Same thing with 23. And what was the time period here? Here we had the 90s and the 2000s. All right, especially the early 2000s. During this time, we had Al Gore talking about global warming. We had a lot of people concerned that the Earth is warming and global warming, and Arctic sea ice melting and stuff like that. So is it possible that the reason why it was so warm in the 90s and 2000s is because of the more active solar cycle, a higher solar maximum? I think so. I think that's a possible explanation. All right. So the 90s and 2000s, 90s and early 2000s, early 2000s, you know, you had unusually warm conditions, okay, unusually warm. If you guys remember the 90s, like when I was a kid, I remember the winters were really not that strong. They really started getting stronger after about 2008 when we entered solar cycle 24. All right, and as you can see, solar cycle 24 is extremely reduced, okay? And the other cycles before 1985 were also fairly high, all right? But for some reason, during the 80s and 90s, solar cycle 22 and solar cycle 23 were extremely active, and the maximum was very high, all right? And then all of a sudden, solar cycle 24 came along, and it was about 50% less than 23, and it was even maybe 30% of solar cycle 22. All right, and we just got out of that now in 2020. Okay, so we're in a minimum right now. They actually, NASA said that we officially entered the solar minimum in April. Okay, April 2020. April 2020. Okay, is when we officially entered the solar minimum for the next cycle, which is going to be cycle 25. All right, so we're in the bottom period now. That's why everybody's saying we're in a solar minimum. Okay. All right, so and so a lot of scientists are expecting what they consider to be a grand minimum. So we may have a very reduced cycle, almost nothing, and they're expecting another Maunder type minimum through 2050. Okay. That's what they're predicting, all right? It's not 100% set in stone. They are predicting a weaker cycle. So cycle 25 is expected to be weaker, all right? They don't know how weak it's going to be, but they know that based on the trend, you can see there's a downward trend here from, you know, 22, 23, and 24 was just a huge cut from 23. It was like 50% less. All right. So a lot of scientists believe that when we get into solar cycle 25, that solar cycle 25 is basically going to be almost nothing. You know, it may be like a little hump, and then that's it. All right. So they think that it's going to be a little hump. All right, even less than what we just went out of. Or it may be the same. It doesn't matter. Either way, it's going to be still much less than these normal size cycles, normal maximums, normal sunspot numbers, okay? And then from that point on, they're predicting a grand minimum, okay? Grand minimum, all right? Through 2050, okay? Through 2050. All right, and again, it's not a guarantee. Nobody knows what's going to happen, but this is pretty much why people believe that there could be a grand solar minimum. And again, you have to study the Maunder Minimum, okay? You got to study the Maunder Minimum and the Little Ice Age, and that's why people believe that the grand minimum could lead to a ice age or global cooling. All right, it's not set in stone. It's not, you know, guaranteed. But it's scientists, and we're talking about NASA. Okay, NASA is very conservative. All right, and NASA is, you know, remember guys, NASA is part of the federal government, and the federal government has all the global warming guys in there. You know, even though we have a new administration. You know, we have the Trump administration, but you still have a lot of the people that work in NASA are still, you know, the global warming crowd, okay? So it's not like the Trump administration went around and fired everybody from NASA. They usually just replace the director or the boss, you know, but they don't replace the other people. But a lot of NASA is saying that cycle 25 is going to be greatly reduced, even less than 24, which we just came out of. All right, April 2020, that's the solar minimum. That's the solar minimum. between cycle 24 and 25. All right, between 24 and 25 is April 2020. All right, so that's why a lot of people think that. So we have the grand minimum to deal with. All right, but we also have this minimum here, which, you know, during these minimums, I mentioned that the weather could be colder. And if you guys remember, in 2008, when we had the minimum period between 23 and 24, we had massive winters, okay, especially up here where I live and in the Northeast and in the United States, even in Europe. In 2008 to 2011, we had some really, really strong winters, okay? And a lot of you guys that live in New York also will probably remember those winters. 2008, 2009, 2010, and 2011 were extremely cold. A lot of Arctic air, massive blizzards. Okay, the blizzards were huge. I mean, I remember over here there was like 2 feet of snow every single week. There was just another blizzard every single week. And we had Arctic air coming down from Canada. It was, you know, some days didn't get above 0 Fahrenheit. Which is cold for this part of New York. You know, I don't live in, you know, far upstate. I don't live close to Canada or anything. So, you know, so during 2008 to 2011, we had really cold winters. Okay, 2008 to 2011 was another minimum between 23 and 24, and we had cold winters. Okay, cold winters. All right, we had cold winters here, you know, during this minimum. Okay, during this minimum, and coincidentally there was also a lot of La Nina activity, and La Ninas favor cold air intrusions from the Arctic, and that has a lot to do with the jet stream, which I'm not going to get into now. I've already killed it with this video. You know, I already bored you guys to death. I'm sure a lot of you guys probably already fell asleep, but so that's pretty much what this all means. All right, and so what you need to prepare for is from 2020 to 2050, the possibility for another grand minimum, another ice age or little ice age. You know, like I mentioned in the beginning of the video. So I hope this video helped you guys. I hope you understand now what it all means. And again, if NASA is predicting a reduced cycle, you know, we definitely have to take their word for it, because they're usually extremely conservative with the solar cycle predictions, because they believe that the Earth is constantly warming, and the last thing they want is a cooling sun and a minimum to make them look bad, you know. So all right, so this is basically what it all means, and I hope you guys enjoyed the video, and I hope you learned something. I'll see you guys on the next one. Let me know in the comments what you want me to do a video about. I'll do a video about pretty much anything related to prepping, and tell me what topics interest you. Are you interested in self-defense? Are you interested in shooting? Are you interested in you know, firearms? What are you interested in? Let me know what videos you want me to do. And that would definitely be helpful. So take care. God bless. And don't forget the 3 Ps. Prepare, practice, and persevere.